Okay, so making this video wasn't easy. I thought I would explain open source, I would help people, they would understand stuff. But as I did research to make today's video, I realized something. Git is an endless ocean. Coders have built it over years, 10 plus years of coding, enhancing it, updating it, and if someone thinks that they can understand Git fully, if they know its technicalities, if they know how it works, then they are either fooling themselves or the people watching them. This is just a very small part of a very big world of Git, because I think it is not possible for a single human being to complete the entire knowledge of Git in their one lifetime, because it is such a big thing. Even if you open the documentation, you will get a book about Git, how it is built, how it works, how data is stored, every single thing. And honestly, everything is based on those same data structures, those trees, queues, stacks, etc., that we have read in our syllabus or in our semester programs. So today we are not going to learn about Git commands. We are not going to learn about GitHub. We are not learning how to push or pull. Today we are opening Git and looking at what it actually is inside. And by the end of this video, you will understand what a hash really is, what a blob object is, what a tree object is, what a commit object is, and how all of these connect together. So if you're a first year student who thinks that Git is like magic, by the end of today's video, it will not feel like magic anymore. Let's begin from zero. Now, before Git, before files, before version control, we must understand one fundamental idea: hashing. Now, a hash is a mathematical function. It takes some input and returns a fixed length output. No matter how big the input is, output size is always the same. In Git, the hash algorithm used is SHA-1. SHA-1 produces a 40-character hexadecimal string. Now here is the most important part. A hash is a deterministic. Means same input, same hash. Different input, completely a different hash. Even if you change one letter, hash changes entirely. That property is called avalanche effect. Now why is this powerful? Because the hash becomes an identity in Git. When we write files, when we save code, we think that Git is looking at files. When in reality, this does not happen. Git gives an identity to every file content. And when you update the file, when you rewrite the code, it just compares the new identities with the previous ones. If the identity is same, there is no updation and just a reference to the previous code. But when identity is different, it regenerates a new snapshot and regenerates that file in the new snapshot. And honestly, Git looks at your code not in the form of files, but in key value pairs, where key is your hashes and the values are the content. Now, every time you want to refer to a particular content that you have written, you use that ID, which is the hash. Now, I will move into the laptop and show you how a hash is actually made. We need to make a new folder, and yes, for today's video, we are going to refer a Git documentation. And if you think reading documentations isn't good, then I think you should understand that even in industry, we refer to documentations, we learn a new concept from there itself, and we just need to know about things. A rough idea would work, where you need documentation to actually proceed. So we are going to refer to Git documentations. So first of all, we're going to create a new directory. If we go to the terminal, I want you to open terminals on your laptops. So when we open terminal, let's create a directory with the name test. Okay, so I already have with this name. Let me do it with git demo. Okay, so next step would be, I'll go into this directory. After this, I need to do something important, but first let's visit this. So we have a shortcut. We can either write git init test and we would directly go into that directory. But since I have not done directly because I wanted to show you how it's done, so now we're going to write git init. Now we have initialized an empty Git repository for ourselves. Let's create a hash. Now, how do we create a hash? We write ECHO, which is a short form of writing a content. We are going to write our content as our first hash demo. Okay. Get hash object minus w minus std in. So here minus w means you're writing something, and std in means you're taking input from the input stream that is in this thing. You're not inputting a file or something. Once we do this, we get this id. If you read check it, it would be a 40 character id, which is hexadecimal. So this is the first hash we created. Now let's make a small change in this. Let's make t capital. You get a different hash. Now this means even a small change would generate a different hash. Now to verify this, let's get back to the same d. We get same id that was generated earlier when we wrote the same thing. So this is what a hash really is. Now let's create, now okay, we'll talk about hashes in files that are blobs in future part. I mean in some time, but here I want to tell you something important. So this is how you write content in Git. But this content isn't stored anywhere. This content is just over here. And if you want to create files like you usually do in your systems, or we create files when you're writing Git repositories, that is where we come to the next part of the video, that is blobs. Now, blob stands for binary large objects. Let's ignore the name. In Git, blob simply means the content of a file. I'm repeating again, not the file, but the content of the file. A blob does not store the file name, the directory name, metadata, or the permissions. It only stores the content. If a file contains text, a blob stores that exact text. If a file contains an image, the blob stores the raw binary data of that image. So, blob is the raw file content. Now, common confusion is that students think blob is a file. No, blob is content of the file. File name is stored somewhere else, and we will see that soon. But let's get to what a blob really is and how we can do it. Let's get into the screen, and I will create a file for this. So this is echo. Let's write the content. For example, our first blob. We'll store this in file that would be um okay, something.txt. So we've already stored this. But then where is our hash? Where are our stuff? We don't really know. Let's check that too. Now I will store this file as a blob in the Git. What we did earlier was just the contents of the file, but we need to store it. So git hash object minus w something dot txt. So this is the hash, but you would say, how do we know it is a hash for a blob? Let's check it. So we do git cat file minus t for type, and we paste this. So this is a blob. Now if you want to see the contents, let's check that. We'll at place of t we're going to write p. So we have the contents, that is our first blob. So this is what a blob really is. Now what if we update the contents of the file? Let's do it again. This is where we created our first blob, this. So we're going to update the content. Second blob, and save it in the same file something.txt. Okay, it's saved. Now let's check what has happened with our file, if something is changed or everything is similar. We're going to copy this thing. We are going to generate a hash for it first. So we get this. Earlier we had something as this, and these are completely two different things. So this means when the contents change, there is a change in the hash related to that content as well. Now we're going to do something that we did previously, but this time we're going to change this ID. So this is again a blob, but we're going to see the contents this time. Second blob. Now, let me explain you what is actually happening and what is important for you to understand. Now, if you have two different hashes, one was for the first content and second was for the second content. If you have two different hashes and you remember those identities, those hashes, then you can actually go back to the content that was kept earlier in that file. But the problem is, who is going to learn all of these hashes? We are never told to save such things. Then how Git actually works on all of these things? And this is something that we're going to cover in the next part, because blob is just the content. And in reality, we do not have content. We have lots of files, we have folders. And how is this actually managed? Now we need to understand how the file names and the folders, how where are they stored and how are they created. For this we have tree objects. A tree represents a directory. Tree stores a structure and it connects the file name to a blob hash. So tree contains more information like file mode, for example, the permissions, the object type like blob or tree, object hash, and the file name itself. If a directory contains another directory, tree stores a reference to another tree. So imagine like a blob is a content whereas tree is a structure. A tree can contain multiple blobs or even multiple trees in it. A tree builds the file system layout. Without tree, Git would only have floating content. You would not be able to structure the things at one place. Now let's understand how do we create a tree and how do we need to do the things in order. So first of all, we need to stage the files, and this is where the git add command actually comes into consideration. Let's create and stage the files and do the things in the next part. Now to work on a tree, we need to do something like we need to stage the file, as I said, git add. We already have a file that is something.txt. We are going to do git add something.txt. Now this file is staged. Git write minus tree. Now we get a new hash. Let's do the same thing that we did earlier. Git hash object minus t to check its type, and this is something that happened. So we need to do git cat file minus t and paste this. We get it is a tree. Now let's check the contents. We need to replace this t with p. We get a lot of these things, and now we need to understand what they are. This tells the type of content which is stored in the tree. This is the ID of that content. This is the file which stores the content, and this over here has something to do with the file permissions. Now, blob did not know the file name. Tree connects the file name to the blob. If I create a folder and add a file inside it, Git creates a tree inside a tree. That is how directories are represented. Trees build hierarchy. Now we have content stored in blobs, structures stored in trees, but we still don't have a history. And this is where we talk about commit objects. So commit object is what people think is saving work, because when we make commits in Git, we just write that one message. But in reality, it is also an object. Commit does not store files. It stores a tree hash, the parent commit hash, author, timestamp, and the commit message. These five different things. Commit points to a tree. Trees point to blobs. This creates a chain and a very important idea. that Git stores snapshots. Now, we always think that Git stores differences in files, different contents of files, when in reality it is just storing a whole snapshot what is actually written in that file. Stage 1, you had 4 different files, it took a snapshot. Stage 2, you have 4 different files, you updated one file. It will keep the 3 files same, write new content of that file and make a new snapshot. Now we are going to make a new commit object in this thing itself and understand how things actually work. Now if you go to the documentation, you can see here commit objects, and this is the syntax that we use to create our commit objects. So echo first comment. So you must have noticed the similarity. We always use the word echo before writing the content. So we will write first commit, then this, and git commit tree, and then we're going to paste the tree hash that we actually got. So this is the tree hash. Let me tell you again, this one, not the one that we have received over here. This is a blob hash, remember it. So we have created our first commit. Now we need to see how things are actually working. We'll do the same thing again. Git cat file -t. We'll copy paste this thing. So this is a commit object that we have seen over here. Let's do it again and let's put out the contents. We get our first commit. Now let's move further. Now you want to write another commit for the same thing. So for this you need to talk about the present tree present branch and the previous commit thing. So let's see how do we do that. Now I will add the contents in the file that we created earlier. Echo Git is a great tool, and here we're going to place it in the file something.txt. Done. Okay, so we're going to stage this file, git add something.txt. We're going to do git write tree. We got a new hash for this thing. Let's check it with the same thing that we did earlier. Now here what we're going to do is git cat file -t and this. So this is a tree that we already know it is. Let's check the contents again. So tree has so many different contents. Now this is a very short thing that I showed you. We can go way more deeper into these things and understand how they actually work. And in fact, for a beginner like us college students, knowing it to the best isn't possible. It needs a lot of practice. It needs a lot of understanding how things actually work and continuous hit and trial to know how things are working, what is required, what can be a mistakes, and initially when you're going to do it for the first time, you would get a lot of errors. But this tells us that Git is no magic. It is not a mystery. It is just a content structured and a history connected to cryptographic hashes, that is, encryptions. If we understand this, we are laying a first step in understanding the foundation of Git. And everything else, the branches, merges, and other things are built on this. So now we can say that we're no longer just using it. We now understand how it actually works. And this is a very small part of understanding Git and its real working in the world. But this short understanding will give you an edge over other people, because now you can see the technicalities of things and how things are actually working. So I think you can absolutely explain a bit of part of these things, and I want you to explore the documentation, the original documentation of Git, and understand how things actually work. And if you're someone who's already experienced in this field, then I would love to connect and know more how the industry uses these things and if they're actually required in the real world and how they work. Now in the next videos, I would be talking about the different courses available online that can give you knowledge of learning Git and other open source programs. These are some of the best resources taught by MIT Harvard professors, but I would be talking them in the next video. I hope you like this video and you must have learned something new. I knew this was way more technical and very tough for a beginner to understand, but this is something that tries to just hit our approach, it tries to hit our critical thinking, and we learn new ways of problem solving. It is all about how much we know and how much we have experimented. So this is just a small experimentation in a big world that we can actually try. So I think we all should try different things, and if you are trying such thing in your college journeys, I would love to know it. So thank you everyone. I hope you must have learned something through this video. Till then, let's make the best out of our college journeys. Bye.